So let's look at angles on the coordinate plane. That's a fancy way of saying, if I wanted an angle 20 degrees, then I'd draw a ray going up 20 degrees, wouldn't I? But if I wanted to get there, instead of going up 20 degrees, I could have gone backwards. Because I was going backwards, because I was going clockwise instead of anti-clockwise, this is minus 340 degrees, because I didn't quite make it a full circle. Or, instead of going up 20 degrees and stopping, I could have kept going and gone all the way around this way, which would make it 20 plus 360 is 380 degrees. Or, instead of going up 20 degrees, I could have gone down 20 degrees. And instead of stopping, I could have kept going. And I could have gotten it that way. And that would have been minus 700 degrees. And I could keep going literally forever. So 20 degrees corresponds with negative 340 degrees, 380 degrees, negative 700 degrees, and literally you could keep going, etc. As another example, maybe I wanted to draw minus 130 degrees. So this one's here. It's minus 130 degrees. Another way to get there, I could have gone this way. So if that was minus 130 degrees, that gap must be 50. So 180 plus 50, 200 wait, I really need a calculator for this. My brain's not working today. 180 plus 50, 230. Oh yeah, because 130 plus 230, yep, is 360. Or I could have gone this way, but not stopped. So negative 130, take another 360, negative 490. Or I could have gone the correct way, but not stopped. Which gives me 230 plus another 360, 590. So negative 130 degrees corresponds with um, 230, negative 490, and 590. Now this is not terribly useful today, but later, if you had your calculator, actually get your calculator out. If you did sine negative 130, then that's negative 0.66. So sine negative 130 equals negative 0.766. Sine 230, it'll give us the same answer. Let me see. Negative 0.766 sine negative 490. This is where I discovered I didn't know. Negative 0.766 sine 590. Negative 0.766, etc. Like you could literally keep going. Just means these angles all correspond with each other because they're all kind of ending up at the same ray. Definitions for general angles. We did this last year. If I've got a circle starting at the center, going out, and it has a radius r, and I draw a triangle in it under this radius, and it goes along to x, and it goes up y, then Sine of that, the angle made in here, that's a theta. Sine of that angle, opposite over hypotenuse, y over r. Cos of the angle, adjacent over hypotenuse, x over r. And tan of that angle, opposite over adjacent, y over x. If instead of that angle I was like over here somewhere, this radius is still r, and this time it was, for example, theta from here, so it's 180 take theta from the start. This time, the amount it's gone up from the bottom is still y, but the amount it's gone across, like this one, is now negative x. So here, sine, and the new angle we've got is 180 take theta equals, I need to be far, I've got a lot more to write. It's still y over r, and here they are both y over r, but cos, and so that is the exact same as sine theta, yeah? Cos of this angle, so that was 180 minus theta, so it was around from the start. This time we've got minus x over r. And if we have a look at these cos ones, that's the minus of the original, so that's minus cos theta. And if I have tan of 180 minus theta, then that's that's y over minus x, which this time, well, that's y over minus x, this is y over positive x. This comes to minus tan theta. We can replicate this for like going down this way. Or we could have had it, you know, going all the way around this way. And we're going to end up with fairly similar things. This is actually the crux of tomorrow's lesson, so I'm not going to go further into it. But you can probably remember, actually, because we did it last year. Let me draw these better. That goes to there. And that goes to there. You can probably remember what they're going to end up with. Let that stew in your head for a little bit. Right now, we're going to talk about some very specific angles. 0, 90, 180, and 270. So for 0 degrees, theta is 0 degrees, which means we're going along like that. So for this one, so when theta is 0 degrees, how far up are we going? We're not going up any. How far across are we going? Well, it's the same as the radius. And the radius is still the radius, yeah? So now we can say sine theta, or sine 0, equals, well, sine was y over r. Here that's 0 over r, which is 0. So sine 0 equals 0. Cos 0, this is 0, not x, theta, is x over r. But here x is r. So that's r over r. So that's 1. Tan 0 is y over x. Y is 0, x is r. So that's 0. Let me move these. Sorry. Okay. Now let's do something similar for when theta is 90 degrees. So this time we're going straight up. So when theta equals 90 degrees, what's y equal? What's x equal? And what's r? Well, r is still r, yeah? But this time, y, we're going r units up, like it's the radius. This time we're going nothing across. So when we come to do sine, cos, and tan, sine 90 was y over r. Here y is r, so we've got r over r, so it's 1. Cos 90, x over r. So here we've got 0 over r, so it's 0. Tan 90 was y over x. So here it's r over 0. It's undefined. You can't divide by 0. Now let's look at 180. Now 180 is when we go straight across this way. So when theta equals 180, what's our x? What's our r? And what's our y? And what's our r? X, we've gone across to minus r. Y, we're nothing up, and r is still r. So that means, where am I going to write this? Other side, yep. Sine 180, y on r. So y was 0, so it's 0. Cos 180, x on r. So it's minus r on r, so it's minus 1. And tan 180, y on x. So this time it's 0 on minus r, so it's just 0 again. 270, so 270 is when we just go straight down. So when theta equals 270, x equals, well, we're nothing across, so it's 0. Y equals minus r, we've gone down to r, and r is still r. So sine 270, which was y on r, is now minus r on r, so it's minus 1. Cos 270, x on r, so this time it's 0 on r, so it's 0. And tan 270, y on x, so here it's minus r on 0, so it's undefined. Undefined. That's a whole lot to take in, but that's what today's about.